All right, class. Here's the extra credit for circuits 2. Looking to do an RLC problem because I think I learned these pretty well and able to talk about it. On top of that, I explained the same question during that one circuits review that we did, so might as well just do it again. So first of all, we can tell it's an RLC circuit because you got both an inductor and capacitor. Not only that, those two are either in parallel or in series with each other. And the reason why we know it's either in series or parallel, or in this case, it's for sure the reason why is because once this switch opens, there's going to be one loop right there, because this part of the circuit doesn't it's not going to be there anymore, and so you just have that left. So first things first, you want to try, when you see an RC circuit, you want to try and find mainly 4 things at first. You want to for sure find the steady state of t less than 0, and then when t approaches infinity, and then of course alpha, and then omega. Let's go ahead and do that. So I'm going to try and find t less than 0. Let's just draw the circuit. So right now when t is less than 0, everything is there. So pretty simple, because that switch is closed. And this is going to be in steady state because it's t less than 0. That means there was no switching event. So that means there isn't going to be any change in voltage or current. So that means everything is in steady state. So we draw our inductor current first, and then our voltage, capacitor voltage. And actually, we can just take this out because since this is open, there's no need that there's no current going through here, and so it doesn't matter. So IOC, so VC 0 minus is going to be 0 volts because DC is across a wire. Because once inductor is shorted, it becomes a wire, and VC is going across a wire, it is 0. Now IL on the other hand, it's going to be I didn't write my voltage. It's going to be pretty much very simple Ohm's law, which is volts over ohms. So 12 over 2 equals. Now let's draw for t is greater than infinity. Switch is open. And this is also in steady state. So once it's in steady state, there is an open right here, open right here. So there's not going to be current flowing through anywhere, actually, because there's 2 opens. So VC infinity equals 0, infinity equals 0. Pretty simple. And then, so looking at the question, it also asks for IC of t after 0. And that's going to be and that's also going to be 0, because if IL is 0, IC is 0. Well, mainly because of that open. So we can just write IC t equals 0. Alright, so you can do this in either order. You can find alpha, omega first, or you can draw the circuits and find the values first. But I decided to do that just cause. So let's go ahead and find alpha. Alpha R over 2L. And a reason why. Oh, actually, and we're gonna use the 8 ohm resistor in this case, because that's the resistance that's in series in both. We're not going to use the 2 ohm because it doesn't really affect the capacitor in steady state. Henry's. That's really going to equal 2. I think the whatever. And then after that, we're going to go ahead and find. Here, let me actually do this so it's more clear. Oh shit. It's going to do this so it's more clear. Go ahead and find omega. And that's literally going to be that. Capacitor value is 0.1 F. And you plug that into the calculator, it equals 2.23 C. Incorrect. 6. So now to know if it is underdamped, critically damped, or overdamped, you compare alpha and omega. In this case, omega is greater than alpha. So when omega is greater than alpha, it is underdamped. Or sorry, other way around. Omega is greater than alpha, it is underdamped. So we would use the D1 and D2 equations. Let me just drag this here. In the meantime, that way we can literally see it. So D1, if you remember, it's IL0, which is 6 amps. 0, so they just equals 6 amps. And D2 on the other hand equals VL, and that is VL0, which is 0. And then plus alpha, which is 2. And then next is going to be IL0 minus IL infinity, which is the same thing as here. So we're just going to put in 6 amps. And that's going to be over omega D. So in some cases, for underdamped especially, we have to find omega D. And that's really going to be this. I'm going to find that right here. Super simple. And you put in the calculator equals 0.9918, and then we'll just make that equal to 1. And then we put that there. It literally simplifies down to 2 times 6 over 1, equals 12. And then when you plug that into your underdamped equation, you should literally get IC of T. And we can use this equation even though it says IL, because IL is ICT. So ICT equals e to the alpha t. In this case, it's just going to be equals 12 sine t, because it's 1t, minus 6 cosine t. And that's going to be multiplied by e to the negative 2t. Negative 2 is from the alpha. And then, where is it? And then plus I infinity, which is 0. So that is literally going to be your answer.